Hello everyone, myself Ashish Desai, Assistant Professor, Sir Institute of Technology, College of Engineering. So today we are going to discuss on the topic of introduction to mobile robots. So mobile robots are autonomous or semi-autonomous system which is capable for moving in the environment, and it is useful for different industries like healthcare, military and autonomous transportations. So the key components are the locomotion, sensors, navigation and control system. So these are the key components for the formulating mobile robots. So while discussing the mobile robot, there are different types. So first is wheel robots. So commonly it is usually in industrial applications. Leg robots is inspired from the biological movement. So two legs or four legs and six legs. So like that, we can formulate the robots that is called as leg robots. Track robots, which is useful in a rough terrain. So different rough areas are there. So we can formulate it for the rough terrain. So we can call it as a tracked robots. Then also we are discussing about the aerial robot, that is case of drones. So it is unmanned air vehicle, so which is called as UAV. So this is also one type of mobile robots. Underwater robots, so that is about remotely operated vehicles, or you can say ROVs, and autonomous underwater vehicles, which is cleaning of the work or exploration of underwater conditions. So that can be utilized for the this underwater robots. So these are the condition where while discussing in the these types of mobile robots. So while discussing the mobile robots, so first method is in a slide number 3, we'll discuss about the locomotion methods. So before that, we are going to discuss the different eras we are using with the mobile robots. So this is about polar robots, so which is designed to transport icy uneven environment. Also the aerial robots, so which is UAV or drones, which is fly through the air. So it is some glimpses we are showing over here. That is home robots. So it is also called as unmanned ground vehicles. That is UJV. UJV means unmanned ground vehicles, which is navigate on dry land or within the houses. So this is also home robots. So underwater robots, which is exploring the underwater conditions. So we use this AUVs, that is autonomous under vehicles. Then designed to be transportation robot, that is to move materials and supplies around the work environment. So that is for the delivery and transportation. Now we discuss about the locomotion methods. So different locomotion methods are available with us, and that should be considered in a differential drive. So two independently driven wheels are there, and that can be considered as a locomotion method. Some is skid steering, so tracked or wheeled vehicles are there. So skidding steering is required. So at that time we can use the skid steering locomotion. So nowadays we are using mostly that is omnidirection. So it is movement in a different orientation. So every orientations it can be run. So that is why it is called as omnidirection drive. That is, we can say holonomic movement also. The next is about leg locomotion, that is about bipedal or quadrupedal robots. So this is about leg robots. So we are formatting for the locomotion robots. So here legs type of working style is there, and that should be happening with the leg locomotions. So here in this the mobile robots we are cultivated for the locomotion, then sensor, navigation and control system. So these are the key area we are finding in the this type of method. So we are discussing in the after locomotion methods, we are going to discuss the sensor in mobile robotics. So lidar sensor is there. So that is for the 3D mapping and obstacle detection. So light detection lidar sensor is there. So this we can use the 3D mapping and obstacle detections. Cameras we are using for the vision based navigations. IMU, that is about inertial measurement unit. It includes the accelerometer, velocity sensor and we can say gyroscope, so which is required for the orientation and the movement of the tracking. So it is required to be IMU unit. Then GPS for the precise locations we are finding from that. Then ultrasonic sensor or infrared sensor, that is about detection of shortage or can say short range of obstacle detection. So obstacle detection we can find out over the infrared sensors mostly. So these are the sensors which is useful for the in a mobile robots. Then nextly we are discussing about the navigation and path planning. So that is about SLAM. So SLAM is simultaneous localization and mapping. So that is building of map and self localization will be displaced, and which is navigated with the help of AI based navigation also nowadays possible. So deep learning and reinforced learning which can give the models of AI, and then we can solve this problem about SLAM. So that is simultaneously map localization and mapping is possible. So in that content, we are also SLAM is about is used mostly in the field robotics. So that is the it should be enabled for the robots to map unknown environment. So while determine their location simultaneously and should be mapped with these conditions, and it is mostly used in unstructured terrains as such as we can say mines, underwater zones, disaster sites, and space exploration. So in main content of the components of SLAM is LiDAR sensor. We are using cameras, IMUs, and GPS for the environmental awareness. So this is about perceptions we are undertaking over the sensors. Then nextly, that is about localization. So it is estimating the robot's position relative to the generated map. So that is about localizations. Mapping we are doing with the constructing a real-time map of environment. Then also we start discussing with the data acquisition, that is about identifying the precisely visited locations according to reduce the human error. So that is about effective of SLAM use. And then we are correcting the potential which different drift are there, so we can work on with the system. Then nextly we are using the different SLAM algorithms. So that is example is extended clamp filter. So this probability filtering and tracking positions will be used, and then we can get the data for the SLAM. Similarly, we can get the graph slam, visual slam. So this we can generate the model in a graphical basis or cameras. We can picturize and detection the mapping errors. So we can finding this by using slam algorithms. So these are the applications of slam which is available in a self-driving cars which is having with fields and exploring the different area, that is Mars and caves and floor scanning and rovers. So this is should be ocean oil scanning. So this kind of actions we are doing with the this type of slam technology with a mobile robot. So this is autonomous vehicles, we can move anywhere. Nowadays the Tata has launched that tractor that is about with AI system. So this responsive method we are developing by this system, and then we are getting the navigations which is in collapses buildings and search and rescue operations. We can use also this condition in a slam, that is for the disaster response. And then after moving into the control system, so PID controllers were using after that smooth and stable movement will be possible. If you say about MMC, that is about model predator control, that is also possible for the optimizing the motion control. Then Lenovo based motion control, it is providing the stability. So every time we are giving the this type of different controllers, we can get the exact control over the stability, as well as we are controlling the that motion and motion with optimized way. So this is the possibility areas we are doing with the different controllers. The nextly we are going to discuss about the applications. So different applications areas are there. So we are considering the autonomous mobile robots in warehouses. So nowadays in warehouses management, so we are using the different autonomous vehicles are there. Then self-driving cars is also available this conditions. If it is broad acre application of the application of agriculture sections, we are using the farming section with that mobile robots is possible. Healthcare industry also we are providing the assistive or surgical robots with mobile assisted systems. Then search and rescue operations, we require mobile assisted disaster response robots. And then also we require in military defense for the surveillance and any emergency conditions, we can finding the gap. So that we are finding with the defense sections also. So now we are at different challenges also in mobile robots. So first is environmental uncertainties, power and battery limitations, then computational demands for real processing. So these are the main challenge areas for the mobile applications. Then after that we are having the safety and ethical concerns. So every time we are getting the fetching the data in safest way, and it is do not collide with each other. So this type of actions or this type of prediction we can do with the different obstacle sensors. We can use the different infrastructure infrared sensors, and we can eliminate the that possibility of that you can say uh, different risk is involved over there. So you can eliminate by the systems. Also main challenge of that is power saving, because battery is the main source which is can be utilized for the completing of the work. So that is to be main area which is focusing the power and that battery limitations. So this is can be consideration over there. Then environmental uncertainty is there, so that can be challenger areas. There is no any areas can be finded over there. So this kind of actions we are doing with the mobile robot. So after that we're discussing the future of mobile robots. So in that content the AI driven advancement in navigation and control. then Swarm robotics for the collaborative task, then human-robot interaction improvements, smart cities with integrated autonomous transportation. These are the future of mobile robots. So every time there is some technologies added over there, so we can doing with the different usage, and then we can accommodate for the different applications. So this is about the future of robotics. So nextly we are discussing the in the conclusion of the mobile robots. So mobile robots are recognized means AI, and it is integrating with nowadays with the AI and machine learning, so which can be able to enhance their capabilities with their efficiency also. And it is about the future development which can be promised for the autonomy and efficiency. So these are the main certainty with the mobile robots. So these are the area we are discussed in this lecture. Thank you.